In this video, we will discuss testing a claim about a mean. As noted previously, it's very rare that we test a claim about an unknown value of a population mean mu, but somehow know the value of the population standard deviation sigma. The realistic situation is that we do not know either the mean or standard deviation. When sigma is unknown, we estimate it with the sample standard deviation S. From the central limit theorem, we know that the distribution of sample means x bar is approximately a normal distribution with mean mu sub x bar equals mu and standard deviation sigma sub x bar equals sigma divided by the square root of n. But if sigma is unknown, we estimate it with s divided by the square root of n, which is used in the test statistic for a t-test. This test statistic has a distribution called the student t-distribution. For the t-test described in this section, the p-value method, the critical value method, and the confidence interval method are all equivalent in the sense that they all lead to the same conclusions. Key elements: n is the sample size, x bar is the sample mean, s is the sample standard deviation, and mu sub x bar is the population mean. This value is taken from the claim and is used in the statement of the null hypothesis H naught. Requirements: the sample is a simple random sample, and either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. Our test statistic is t equals x bar minus mu sub x bar over s divided by the square root of n, and we round t to 3 decimal places. For p-value method, we use technology or the t-distribution, table A3, with degrees of freedom given by df equals n minus 1. For critical values, use the t-distribution with degrees of freedom given by df equals n minus 1. If table A3 doesn't include the number of degrees of freedom, you could be conservative by using the next lower number of degrees of freedom found in the table, or you could use the closest number of degrees of freedom found in the table. This t-test is robust against a departure from normality, meaning that the test works reasonably well if the departure from normality is not too extreme. Verify that there are no outliers and that the histogram or dot plot has a shape that is not very far from a normal distribution. If the original population is not itself normally distributed, we use the condition n is greater than 30 for justifying use of the normal distribution. But there is no exact specific minimum sample size that works for all cases. Sample sizes of 15 to 30 are sufficient if the population has a distribution that is not far from normal, but some populations have distributions that are extremely far from normal, and sample sizes greater than 30 might be necessary. In this test, we use the simplified criterion of n is greater than 30 as justification for treating this distribution of sample means as a normal distribution, regardless of how far the distribution departs from a normal distribution. Here are some important properties. The t-distribution is different for different sample sizes. The t-distribution has the same general bell shape as the standard normal distribution. Its wider shape reflects the greater variability that is expected when s is used to estimate sigma. The t-distribution has a mean of t equals 0, just as the standard normal distribution has a mean of z is equal to 0. The standard deviation of the t-distribution varies with the sample size and is greater than 1, unlike the standard normal distribution, which has sigma equals 1. As the sample size n gets larger, the t-distribution gets closer to the standard normal distribution. Times of sleep in hours for randomly selected adult subjects are listed below. Here are the unrounded statistics of this sample. N equals 12, x bar equals 6.83 repeating hours, and s equals 1.9924098 hours. A common recommendation is that adults should sleep between 7 and 9 hours each night. Use the p-value method with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. The sample is a simple random sample. The sample is size is n equals 12, which does not exceed 30, so we must determine whether the sample data appear to be from a normally distributed population. The histogram on page 389 of the textbook indicates that the sample appears to be from a population with a distribution that is normally distributed. Both requirements are satisfied. Step 1, the claim that the mean amount of adult sleep is less than 7 hours becomes mu is less than 7 hours when expressed in symbolic form. Step 2, the alternative in symbolic form to the original claim is mu is greater than or equal to 7 hours. Step 3, because the statement mu is less than 7 hours does not contain the condition of equality, it becomes the alternative hypothesis H sub 1. The null hypothesis H naught is the statement that mu equals 7 hours. So H naught is mu equals 7 hours, the null hypothesis, and H1 is mu is less than 7 hours, the alternative hypothesis and original claim. Step 4, as specified in the statement of the problem, the significance level is alpha equals 0.05. Step 5, because the claim is made about the population mean mu, the sample statistic most relevant to this test is the sample mean x bar, and we use the t-distribution. Step 6, the sample statistics of n equals 12, x bar equals 6.83 repeating hours, and s equals 1.9924098 hours are used to calculate the test statistic as follows, but technologies provide the test statistic of t equals negative 0.290. In calculations such as the following, it is good to carry extra decimal places and not round. P-value with technology, we could use technology to obtain the p-value. Page 390 in the textbook shows results from several technologies. We can see from these displays that the p-value is 0.3887 when rounded. The SPSS display shows a two-tailed p-value of 0.777, so it must be halved for this one-tailed test. Step 7, because the p-value of 0.3887 is greater than the significance level of alpha equals 0.05, we fail to reject the null hypothesis. Step 8, because we fail to reject the null hypothesis, we conclude that there is not enough sufficient evidence to support the claim that the mean amount of adult sleep is less than 7 hours. If suitable technology is not available, we use table A3 to identify a range of values containing the p-value. In using table A3, keep in mind that it is designed for positive values of t and right tail areas only, but left tail areas correspond to the same t values with negative signs. The adult sleep example is a left-tailed test with a test statistic of t equals negative 0.290 when rounded, and a sample size of n equals 12. So the number of degrees of freedom is df equals n minus 1 equals 11. Using the test statistic of t equals negative 0.290 with table A3, examine the values of t in the row for df equals 11 to see that 0.290 is less than all of the listed t values in that row, which indicates that the area in the left tail below the test statistic of t equals negative 0.290 is greater than 0.10. Table A3 allows us to conclude that the p-value is greater than 0.10, but technology provided the p-value of 0.3887, which with the p-value of greater than 0.10, the conclusions are the same as in the example with technology. Hint, because using table A3 to find a range of values containing the p-value can be a bit tricky, the critical value method might be easier than the p-value method if suitable technology is not available. For the critical value method, we use the same adult sleep sample, which is again a left-tailed test with test statistic t equals negative 0.290 and sample size n equals 12. So the number of degrees of freedom is df equals n minus 1 equals 11. Given the significance level of alpha equals 0.05, refer to the row of table A3 corresponding to 11 degrees of freedom and refer to the column identifying an area in one tail of 0.05, significance level. The intersection of the row and column yields the critical value of t equals 1.796, but this test is left-tailed, so the actual critical value is t equals negative 1.796. The figure below shows that the test statistic of t equals negative 0.290 does not fall within the critical region bounded by the critical value t equals negative 1.796. So we fail to reject the null hypothesis. Our conclusions remain the same. Yet again, for the confidence interval method, we use the same adult sleep example, which is, once more, a left-tailed test with significance level alpha equals 0.05. So we should use 90% as the confidence interval as indicated by table 8-1 on page 360. For the sample data given, here is the 90% confidence interval estimate of mu. 5.80 hours is less than mu is less than 7.87 hours. In testing the claim that mu is less than 7 hours, we use H naught is mu equal to 7 hours, but the assumed value of mu equals 7 hours is contained within the confidence interval limits. So the confidence interval is telling us that 7 hours could be the value of mu. We don't have sufficient evidence to reject H naught is mu equal to 7 hours, so we fail to reject the null hypothesis and arrive at the same conclusions.